Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 20 times x minus 3, and that's going to be your answer. For the math knowledge question, we don't know about maximum value here. We don't have enough information to know for sure. We don't know that y is going to have to be less than or equal to 0. All of the y values they give us are, but we don't know that for sure. They only give us 3 points on our function. For this one, symmetric, we don't know if it's symmetric to a line because they only give us 3 points. The only thing we can discover is it a line or a parabola? And so if it's a line, the slope between all of the 3 points should be the same. So the slope between points 1 and 2, y minus y over x minus x is going to be negative 5 over negative 1, which is just 5. And the slope between points 2 and 3 would be y minus y over x minus x, which would be negative 4 over negative 2, which is 2. So the slopes aren't the same between those three, so it cannot possibly be a line. That's the only one that we know for sure. It cannot be a line. The A, B, and C, we don't know. We don't have enough information. E, it could be a parabola. We just know it cannot be a line. So if you're not sure about, I don't know what A, B, and C, I don't know what those are talking about. Start with the ones that you can prove if it is or is not. The line and the parabola would be ones that you would want to start with there. Okay, so we're looking at lesson 14 today, limit of a function. So we started a lesson on limits a couple days ago. We're going to continue looking at limits. So a function has a limit at a particular value of x if it has both a left-hand limit and a right-hand limit, and those two limits are equal. So that's what I was telling you about in lesson 11. That you can have a left-hand limit, you can have a right-hand limit, but at that particular value, it only works if the left and right hands are the same. So if we look at this function here, we can factor that, and it's going to be x minus 3, x plus 2 over x minus 3, and so your function's really just going to be x plus 2. And that's what they have graphed right here, just a line. However, you cannot have a 3 minus 3 in the denominator, so that's why they put a little hole here at 3. There's a little dot. So the limit as we approach 3 from the right is going to equal 5. As we're coming from the right here, the limit is approaching 5. What about as we're coming from the left? What would the limit as we approach from the left be? If you come from the left here, you're still approaching the same point, which is 5. So from the left, the value is still going to be 5. What about the limit at 3? As x approaches 3, what would the limit be? Since the left and the right-hand limits are both 5, the limit at 3 is also going to be 5. Even though when we plug in 3 into the function, it doesn't work, the limit is still 5. So that's how limits work. So what is the value of f of 3? But the limit of it is 5. So just because the function doesn't exist at that value doesn't mean that you can't have a limit. Alright, so we want to evaluate this. So you want to try and plug in. If you try and plug in and it doesn't work, then you want to factor. So if we plug in 2 here, we get 0 over 0. We can't do that, so we're going to factor this. So you always keep the limit whenever you are working with it until you have actually evaluated it as x approaches 2. So x minus 2, x plus 2, and then x minus 2. So those x minus 2's cancel, and we're left with the limit as x approaches 2 of x plus 2. And so now you can plug in 2, and so 2 plus 2 is 4, and so that is the value of that limit. And that's all you have to do with limits. So looking at another one, we want to evaluate this. First thing you want to try and do is plug it in. If you plug in 3, you don't get divide by 0 error. You get 3 squared, 9. 2 times 3 is 6. 3 plus 1 is 4. So you get 15 over 4. It's really just a trivial question because you're basically just plugging it in. You didn't have to do anything with it. So that's your answer for that one. So that's why you always want to plug it in first. See if you can save yourself any time. Okay, looking at this one. If we try and plug it in, we can't do anything with it because we get a 0. So we try and factor. If we factor it, we can factor out an x, and we have x plus 6 over x minus 3. Can we factor anything from, can we cancel anything after we factored it? No. So we already tried to plug it in, it didn't work. We factored it, and we can't simplify it anymore. So this limit does not exist. And so that's your answer. Okay, so let's look at this next one. We want to try and plug in. Can we plug 2 in here? Well, if we plug in 2, we get 2 minus 2 is 0. 2 squared is 4 plus 4, so that's 0 over 8, which you can do is just 0. So that's your answer there. That's all you have to do on that one. Just plug it in. Looking at this next one, can we plug in -1? No, you can't plug in -1, so we need to try and factor it. So in the numerator, we're going to have to factor using remove, replace, reduce. Those are my cursive S's, in case you're wondering. My S's start to look too much like 5s if I write them non-cursive. So if I'm going to factor this, I'm going to have s squared plus 5s plus 6, because you have to remove the 2 and multiply it by the 3. If you factor that, you get s plus 6, s plus 2 and s plus 3. And then you replace the 2, and then this first one reduces to s plus 1. But the second one won't reduce, so you leave it as 2s plus 3. And so that's how it factors. And now if you look, you do have a cancellation that can happen. S plus 1 cancels. And so now we're left with the limit as s approaches -1 of 2s plus 3. And so you can plug in -1 now, which gives you a 1 for your answer. So that's how that one works. Now if you look at this one. So for this one, you're going to want to try and plug in, and if you plug in, it's not going to work. So you're going to want to factor. And you may be trying to remember how to factor x cubed minus 8. That is a difference of cubes. And so your formula, if you have a minus b, a cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. And so that factors as x minus 2 and then x squared plus 2x plus 4. So the x minus 2's cancel, and you're left with the limit as x approaches 2 of x squared plus 2x plus 4. So you can plug in 2 at this point, Whoops. And so you get 4 plus 4 plus 4, which is 12. And so that's your answer for that one. Looking at the next example, we want to evaluate this one as x approaches 0. So if we try and plug it in, obviously that's not going to work because you can't divide by 0. So we're going to start off by simplifying this numerator. The way they wrote it is kind of strange, so we're going to try and make it a little bit easier to understand. And so if you factor x plus 3 squared, you get 9 plus 6x plus x squared, and then minus 9. So those 9's cancel. So you have the limit as x approaches 0 of x squared plus 6x over x. And we have an x in all three terms, so that x will factor. And so we end up with x plus 6. And then if you plug in 0 for your x, you just get 6 left. And so that would be your answer for that one. For the next one, it wants us to use a graphing calculator to confirm that the limit does equal 6 on that last example that we just did. So you're going to go to y equals, and you're going to plug in this equation. So 3 plus x squared minus 3 squared all over x. I'm going to change my window. And I'm going to graph it, and that's what it looks like. It's a line. The way that you confirm the limit is to go to table. And so if you look, as we approach 0, from the left and from the right, we go from 2, 3, 4, 5, we get an error, 7, 8, 9, 10. So what do you think at 0? What's the logical number that's in between these? 6 would be the answer that you're looking for. So that's how you can use the graphing calculator to confirm that one. Okay, so your homework on tonight, you get to omit part B of number 13. It's asking you about a half angle identity, and so you don't need to worry about doing that one. I'm going to go back to this worksheet that I pulled up a couple of days ago. If you want to practice some more limits, like what we were doing on the lesson today, you would try 1, 2, 3, 4, 8, 11, 12, 13, 14, 15. Those would be some that you could try through. You could also look at some of these, although they may possibly be a little bit harder. Number 3, 7, and then again the answers are going to be down here, so I'll pause there for just a second. So if you want to look through those, that would be a good place for you to get more practice than what's in the book. So hopefully these aren't too bad for you, and you can go through limits and get a little bit more confident with them.